Inheritance, right? Inheritance is one of the important topics of object-oriented programming, and it's a different concept. So it's important to understand, again, the mindset behind this. We created objects. We created first classes, and then we created objects of these classes, and then we used them in our program. We created programs, right? But you remember we said object-oriented programming is trying to resemble the real world, right? So what if I have a class right now, but then I want to create another class that gets some features of the original class? One example would be, you remember we discussed this dog object, that it has its own methods and actions and features, right? It has 4 legs, and then another method would be it bark, it run, does something, right? What if this dog as itself can be part of another bigger class that we can call animal, right? Because it shares features with cats, it shares features with horses, it shares features with other things. So instead of creating a class for every single object in the real world, you can create generic classes, like for example the animal class that I mentioned, that has generic features, and then it has subclasses, child classes out of the generic class, which we call a parent class, and then these subclasses can specialize in something. So out of the animal generic class, you can have a dog class, a cat class, like a horse class, something other than this, right? So we call the generic class a parent class, and then we call those subclasses like a subclass or a child class. This is basically inheritance, which means you take some features from another class, so you consider to be a son, a child of that class, right? So how to do this in Java? If you have an old class that we define using just the normal way, now you can define another class to be a child or a subclass of this one by using the reserved word extends. Public class, new class, this is the way that we used to define classes before. Now, by adding these things, we are also telling the compiler that this class will inherit all the features of the parent class. So all the members, all the methods, as if they are copying them from the original class to the new class. So this saves your time, right? So now the new class extends the old class. By doing this, the new class inherits all the features of the original class. In addition to this, the example that I give you, the animal thing, and then you have the dog, cat, horse. So there are some generic features that all the childs will have, but also each child will have its own features, right? So the new class, the subclass, will inherit all the members and methods of the original class, but also can define its own methods and members, right? And fields. And this makes sense, because otherwise, if it's just the original class with all its features, then why define a new one, right? So every one of us, you have your parents, so you get some features from them, but you have your own personality, right? The same thing. So you get some features from your parents, but you develop your own way over the time. So a child class will get all the features of the original parent class, and then define its own members and methods. Is there any question? So we call the old class a parent class, base class, super class. All these names are valid. Then we call the child class, derived class, subclass. Also, all these names are valid. But again, this is not something that is specific to Java. This is an object-oriented programming concept, which you can do in C++, you can do in Python, you can do in other things, right? So the good thing about object-oriented, or what we cover in this part of the course, is we take the syntax in Java, but the concepts apply to any other object-oriented programming language. Good? So let's see how to create one. So this is our original point class. Again, we visited this multiple times. Great. So now, before jumping into how to create, let me just ask a question before going into this. This is exactly the class that we had before. Forget about the toString method right now. But it has one other difference from what we did before. Can someone spot what is this difference? How this implementation is different than the thing that you guys implemented in the previous 2 lectures? One very important difference that we need for inheritance. Here. But here, I mean, previously we called it set, but now we call it set point. It doesn't really matter, right? Or set x, set y, it's the same thing. Yeah, so this is the main difference here. X and y previously, what was the previous type we had? Private, right? Previously we had X and Y. If you remember, we started X and Y as public, and then I told you that this is not a good programming skill because a user have access to them, and then we moved them to be private, and then we had set and get for them. Now we changed private to be protected. What is the reason for this? The main reason is if you define a variable as private and you are a parent class, your child class will not have access to the private variables. Right? So private members, whether they are private variables or private methods, are not accessible by subclasses. Good? On the other hand, protected instances, protected fields, protected methods, you can access them in the subclasses or child classes and access them within the same package. So a user cannot access a protected member from another package. So you still protect them, but you have some flexibility over private, which means if a child class is extending you, then it has access to those protected methods. So this is the main difference. If we define X and Y to be private, now when we create a child out of a point class, it will not have access to X and Y, right? But by using protected, you still protect X and Y from the user, so we still apply the security concept of OOB, but you allow child classes to have access to them. Good? Okay. So now let's create a child class out of the point class. Previously we created a completely different class that we called circle, and then inside circle we had to define an object of point. Do you remember this? With this last lecture, which we called class composition. Right? This was our previous lecture. So inside circle class we had to define an object of point and then do all kinds of things inside the circle class. Now, an easy way to do this, we did this in the last lecture because we didn't know inheritance, right? But using inheritance, you can make the circle class an extension or a child of a point class, and that means now you have access to X and Y, and you need to define another object, so it's much easier, as we will see. Good. So by doing this, you create another circle class that extends point. Great. By doing this, you have access to X and Y right now because they are protected, and also you have access to all the public methods of the point class. So now, if this was our original point class, this is our new child circle class that extends point, and then what we do is you have your own constructor, which you call circle. We will come into what happens when you call this constructor right now. But then also you have access to X and Y, and then you define, in addition to this, you define your own member, which you call radius. So this is telling us that as a child class, you inherit everything from the parent, but you still can have your own stuff. So radius right now is accessible by circle, but the question is radius accessible by point? Can an object of a point class access the radius variable? What do you think? Yeah? Yes, not the other way around. So circle is the child of point. So point does not have access to the members of circle. Circle has access to the members of point, right? Good? So this is inheritance. You take from the parent, but the parent doesn't take anything from you. Good. So radius is a member of circle, and then this is a constructor of circle itself. It takes three variables, r to initialize the radius, a and b. What we have done before is, in this case, we needed, you remember last time when I asked you to implement this, we needed to create an object inside the constructor of type point and then initialize it using a and b. Right now we don't need this. We are using what we call super. I'll come into this point later, but this means you are just calling the parent class and you initialize it directly by a and b without defining an object or anything. Why this is possible? Because as a child of this parent class, you have access to everything. Right? And then now we set the radius of r. This set radius is another method of the circle class. We also had this before, no change here. So the main change of this implementation from what we have seen last lecture is the interaction between the circle class and the members of the point class. Previously, we needed to create an object of point inside circle to be able to access those x and y. Now we don't need so, because circle is a child of point, right? Great. So is there any question in this code? Yeah. If they are on the same package, right? But it's not necessarily that parent and child are on the same package. You can have them in, but generally if they are on the same package and they are protected, then yes, all right. Yes. There was a question here? Yeah? You can change, you can do whatever, you have access to it, right? Not the user, right? So there is a big difference between, previously we had only two things in our security equation, the user and the creator of the class, right? Right now we added something in between, which is a child of that class. A child of that class is something between the user and the creator. So it's not a user, but it's not the creator, right? So the child can modify x and y, but the user cannot change x and y, right? What do we mean by a user? Someone who is instantiating an object in a completely different class, in a main, for example. Yeah. If you want to change the value of x and y from an object in another class, or inside the child. Inside the child, you can do something like this. You are initializing a and b by calling the constructor. Or you can even say x equal and y equal and it will work, right? Yeah? So you can hard code it and it will be allowed. Good. So this is our circle class. What happens, right? So why do we need to call the super thing here? So I told you that a child will inherit everything from the parent, including methods and fields or variables, right? But constructor again is a special thing. Constructor is not a normal method and it's not a variable. It's not something you can invoke yourself. You cannot call yourself, right? It's just, when a constructor is being called. Very, very basic question, yeah. When you create an object, right? When you instantiate an object of this and initialize it. And if you don't initialize, by default, you call the empty constructor, right? Because of this nature of constructor, a child will not inherit the constructor of the parent. And this is very important to understand. This is why we needed to call here super A and B. Super means call the constructor of my parent, right? So you initialized R using your own method, but also you need to initialize X and Y. And how would I initialize them? You call super, which is the constructor of the point, and pass A and B to it. Just doing this super thing here will go ahead and call this constructor, which internally will set point X and Y. A question, was there a different way to do this rather than calling the constructor through super? Would I be able to initialize X and Y in another way? Yeah, you have access to all the methods, including this set x, set y thing, set point here, right? And then you can call it directly. So we can do this as well, right? Good. Okay. So we already explained the super thing. So one important notes about the super thing is, what if I didn't call the super here? So what if I didn't call super by doing this? So one feature of a child class, once its constructor is called, so let me give you this example. Now we define circle as a child of point, right? In a main, I'm creating an object of circle, like say circle C1 equal new circle, right? I just told you right now is by defining an object, you call the constructor of that class. That means the constructor of the circle, which is this one, is going to be called, right? Something that is very important, because circle is a child of point. Once the constructor of the child is called, the constructor of the point is going to be called directly. So by default, even if you didn't use this, the first line of the constructor of the child, the compiler will be calling the constructor of the parent. Okay? So what if I didn't do this myself explicitly? That means you didn't call a constructor. Do you remember what happens if you don't initialize things using the constructor yourself? If you create an object of a point and you didn't pass x and y, what would happen? Yeah, like the general thing is the constructor that has no input parameters will be called by default. I also told you before that every class in Java will have a default constructor, even if you didn't define it yourself. This default constructor takes no input, right? And then it's just an empty constructor, but it's being called by default. Good? If you didn't pass anything here, then there are one of two alternatives that we will see right now. You either had an empty constructor in your implementation of point, that means it's okay, this empty constructor will be called, or if you didn't add the empty constructor yourself, then you will have a compiler error. So let's see this, because this is kind of confusing, I guess. Okay, so let's take some examples about what I just said right now, right? And we will conclude by this. So here we have a class that we call A1, and then it has X, which is protected, that's okay. And then we have another child class that we call B1 that extends A1, which means B1 is a child of A1. And this is the constructor of B1. Good? This constructor does not call the constructor of A1. So it doesn't say super and pass something, right? And then it said this.y equal y, which means it only initializes its own member and it does nothing with the parent class. Here it's written that this is a compiler error. Why this is a compiler error? It's a compiler error because I told you if you don't have an explicit call to the parent constructor, the compiler will have to call it by default. Which constructor the compiler will be calling? It's the empty constructor. Is the constructor that takes no input parameters. But in your implementation of the parent, you didn't have any empty constructor. This is why it gives you a compiler error. Okay? So let's see another example that will make it clear. If I just added, the only change that I made from this slide to this one is I added the super 5 thing. What does super 5 do? Yeah? It calls this A1 constructor and passes 5 to X, right? By doing this, that means you told the compiler to call this constructor and then you have no issue, right? So here there is no error. Great. So let's see another case. Here also there is no compiler error, but we didn't use the word super. So what did happen? This is also another trick, yeah. Not just that. The important thing, yeah. There is no constructor here. Yeah. So what happens? Why this is doesn't have an error? Even if it's not the answer that it doesn't have a constructor, because I told you by default it calls the empty constructor. And if you don't have an empty constructor in the parent, then it gives you an error. Here it didn't give you an error because you give an initial value for x. The Java compiler, if you initialize a variable, the way it initializes this variable is to define its own constructor that passes 5 by default to x. So here, implicitly, there is a constructor that is being created to initialize x because you added an initial value for x, right? Right? So here, we just solved the problem directly by having the empty constructor, which means it just takes nothing. And in this case, even if we didn't use the word super, the compiler will call the empty constructor by default, but I already have an empty constructor, then it's fine, right? So the last thing that I want to mention is a very good programming skill that takes you out of this headache is to do what? For every class you